Welcome to This Is My Architecture. My name is Kurt, and today we're here in New York City, joined by Tom from Accenture Cloud Platform. Why don't you tell us about the platform?
Okay, so we manage customer accounts in public cloud, providing governance and analytics and cloud management services.
Yeah, thank you. As a matter of fact, Tom, you're joining us for the second time.
That's right.
And we're going to talk about an architecture we talked about before, but you guys did a significant pivot on. Why don't you remind our viewers of the architecture we're covering here?
Okay, so the Accenture Cloud Platform is based on an inventory service that contains all the resources that the clients have in the cloud. And we have a discovery process that we run which pulls that information from each account and stores it in our Elasticsearch repository, which is our inventory system.
Tom, give our viewers an idea of just how many accounts you cover with this solution.
Sure. So we cover about 4,000 accounts, and we try and discover them, because cloud estate changes so frequently, about every 10 minutes.
Okay.
So we run a time-based trigger out of CloudWatch, which launches our collective service across 4,000 accounts in every region and discovers every resource type once every 10 minutes.
So 4,000 accounts, lots of resources. I would assume that's a massive amount of jobs.
Our collector process runs as many as 10,000 concurrent Lambda jobs running at a time. Each of those Lambda jobs writes its collected output into S3, and then each of those outputs triggers an S3 event that launches a difference engine, which also runs about 10,000 concurrent processes. Each of those difference engines compares to the previous run, and if there's a difference, writes that to S3, and then those S3 events trigger our publisher, and our publisher then pushes the data into Elasticsearch, where it becomes part of our inventory.
Great. So 4,000 accounts, lots of Lambda invocations, thousands of Lambda invocations to arrive at the inventory at the end. You told us about a change you made. What did you change?
So we were running into issues where the Lambda functions were not being as efficient as we would like. Because we were timing it, they were running all in 5 seconds at the beginning of every minute, and we didn't have convenient ways to spread that out. And so we looked around for what we could do to smooth that out and to make more efficient use. And so we found that we could swap out the Lambdas for the collector with Fargate.
All right. Interesting change. Did you just change the collector process, or did you make multiple changes?
So we changed both the collector, and then we also changed the difference engine, because both of those were the services that ran to about 10,000 concurrent processes. By switching the collector to be account-based rather than resource type-based, we're able to then discover all the different resources in all the different regions within a single collector container execution. That then enabled us to make a number of efficiency choices having to do with memory, but also having to do with API calls for things like authentication, which we had to do multiple times, once from each Lambda. Now we could do that once for each account. And then in the difference engine, we could process these larger files that were being written out by the collector, but then still write the same smaller publisher files that were needed to get the changes into the inventory.
So let me make sure I understand that correctly, Tom. The pivot to Fargate, so to containers, was driven mainly by efficiency and to utilize the runtime better and the memory utilization better. Is that correct?
It also had the benefit of driving costs down a little bit because of the way that we were running it. So because each Lambda function was exactly the same size, not mattering whether it was a large or a small discovery, right, the amount of memory we had to allocate for the Lambda functions needed to be as big as the biggest one. By putting it into a container, we were able to just allocate enough for the entire account within that container. Plus, we could make some more efficient choices around, information that we already have about those accounts and so forth.
So this is a fairly significant pivot in your architecture. It's still serverless, but you went from Lambda to containers. Help our viewers understand how your development community made that transformation.
Sure. So whenever we look at one of these sort of microservice components, we're trying to figure out what will make it run more effectively, more cost efficiently. And we were seeing that the hardest thing for us to really even get a handle on was all of these processes that were running concurrently. It was difficult for us to tell if we were seeing increased concurrency because of an issue or whether it was just a lot of things being discovered. And so by smoothing it out using the Fargate container, we're able to much more easily see where those concurrency spikes happen. We don't run into limits for the account for number of concurrent processes. And honestly, we run into a lot less throttling by the number of API calls we're making.
Yeah. So this is a terrific example of taking a application that's already deployed on the platform and successfully running and continuously evolving it and driving improvements into that, in this case, on a pivot from a Lambda to a container. Tom, thank you so much for sharing this. I'm looking forward to seeing you hopefully in a couple of months with some more iterations on your architecture.
Thank you.
Thank you for watching This Is My Architecture.